pressure is defined as the force exerted per unit area, but I like to think of it as how spread out is the force. We can spread that force out over our entire hand, or we can exert that force with just a fingertip. And so depending on how we apply that force, we'll have a different amount of pressure. Even though we have the same amount of force, different amount of pressure. Pressure is a scalar, has no direction. We use the symbol P for pressure. The equation that we get from the definition, it is force per unit area, so it's force divided by area. This gives us units of newtons per square meter, which is abbreviated as a Pascal, or PA for short. That is not the only unit that we could use for pressure. We can also use things like millimeters of mercury, used by either nurses or perhaps by meteorologists. PSI, which stands for pounds per square inch. This would be used by mostly the United States, and especially mechanics who use PSI. Then there's atmosphere. How much pressure does 1 atmosphere of air exert on an object? So what are some things that affect pressure? Well, we can see from our equation that force and area affect pressure. The larger the area, the smaller the pressure. So they are inversely related to one another. That's why area is in the denominator. We can see this by if we lie on a bed of nails. The more nails, the better, because more nails means more area, and more area means a smaller amount of pressure. We can also look at it this way here and go back to that example of if we exert a force with our hand versus if we exert that force with our finger. If we exert the force with our hand covers a much larger area than our fingertip. And so we have a larger amount of pressure if we exert that force with our fingertip than if we exert the force with our hand, because there's a larger area with our hand. The other thing that affects pressure is the force. And the larger force that we exert, the greater the amount of pressure for the same amount of area. And we can again go to that bed of nails and explain it this way. We can explain it, the pressure for every nail. If you have just one nail, each nail would have to support your entire body weight. So if you have 2 nails on your bed, each nail would have to support only half your body weight. If you have 3 nails, each nail would have to support a third, and so forth and so on. So the more nails, the less force each nail has to exert, and less force, less pressure, and so the nails will not puncture through your skin. Going back to these two and giving one more example here with just the design of a nail, we see that a nail has a very small area at the tip. And that's why we're able to, when we hammer with a nail, it goes through the wood. If we're to flip that nail around and try and hammer with that nail, we have a larger area on the head of the nail, and so that would not, of course, go through the wood. And so the smaller area will give us a larger pressure for the same amount of force. The next thing that affects pressure is how deep you are in the fluid. The deeper you go in a fluid, the larger the pressure. And so this is why when we go down and we scuba dive, you've got to be careful because the pressure on your body increases. Now what this will do is it will actually allow more nitrogen to dissolve in your blood. Now as you come back out of the water, what's going to happen is the nitrogen will come out of your blood and collect at your joints, like your elbows over here. And so if too much nitrogen collects at your joints, it might burst the blood vessel and therefore might cause some internal bleeding. Going back to blood pressure here, we always take your blood pressure at your upper arm. And the reason is because we really want the pressure of your heart. And so we need it to be at the same height as your heart. The height in your head is going to be less pressure, or the pressure in your head, will be less, because the height is higher. And the pressure in your feet will be greater, because it's at a lower depth. When we go up in an airplane, we see that the airplane the cabin is pressurized, because as we go up there is less pressure, and that would cause us some discomfort. And what happens is your ears pop to alleviate that imbalance of pressure, and this will cause some problems. So we just pressurize that cabin to help alleviate any of those problems. Now, how much pressure does the air exert? The air exerts 101,300 pascals, or 17.4 psi, pounds per square inch of pressure when we're at sea level. So why are we not crushed by all that pressure? Think about it. For every square inch of your body, there is 14.7 pounds of air pressing on you. And so why are we not crushed by all that? Well, the reason is because there is pressure inside of us, which is going to be pushing outward. So the air pressure pushes in, the pressure inside pushes out, and it bounces. If there's that imbalance in pressure, that is what's going to happen. Our ears are going to pop to help alleviate those problems. Next we have suction. Suction is caused by that imbalance in pressure. So if we have pressure greater at one point than another, objects always move towards the smaller amount of pressure. And finally, we have Pascal's principle that says if we were to increase the pressure at any given point, that will increase the pressure equally throughout the fluid. So that's why if we take a Coke bottle and we perhaps squeeze the Coke bottle at the bottom, it will increase the pressure everywhere and cause the liquid to come out the top.